Good morning. Welcome to another video, and in this video we will discuss midpoint formula and division of line segments. Our goals in this lesson are to first, determine the midpoint of a line segment, and second, solve for the points that divide a line segment. Now let us start with defining the midpoint formula. The midpoint formula is applied when one is required to find the exact center point between two defined points. Now consider a line segment placed on a Cartesian plane. The two endpoints of the line segment represents the defined points. Now using the midpoint formula, we will be able to find the coordinates of the point that lies on the middle of the line segment. Now let's try to analyze this. Let x prime be the coordinates of the midpoint between two different points on a scaled line, which will be shown on the figure below, with coordinates x sub 1 and x sub 2. So we have x sub 1, we have x sub 2, and on the middle we can find x prime. Find the value of x prime. Now if we can observe, x prime is on the middle of x sub 1 and x sub 2. Now basically, if we will try to find the middle of two numbers, the concept we will apply is getting the average value. So on the same way, to get the value of x prime, that would be equal to x sub 1 plus x sub 2 over 2. Now let us try to find the coordinates of the midpoint between the points A and B, where A is -4 and B is 3. So using the formula that we have earlier, x prime is equal to x sub 1 plus x sub 2 over 2. We will substitute the values of A and B, which are -4 and 3. So simplifying the numerator, we'll have -1 over 2. So therefore, the coordinates of the midpoint between the points A, -4, and B, 3, is -1 over 2. Now let us try to find the midpoint of a line segment. Let P, with coordinates x, y, be the point of the segment joining the point P sub 1 with coordinates x sub 1, y sub 1, and P sub 2 with coordinates x sub 2, y sub 2. Find the midpoint of P sub 1 with coordinates x sub 1, y sub 1, and P sub 2 with coordinates x sub 2, y sub 2. So let us consider this figure. So we have here the first point with coordinates x sub 1, y sub 1, and our second point, P sub 2, with coordinates x sub 2, y sub 2. So if we will look at our x and y axis, the value of x here in our x-axis is x sub 1. The value of x here on the x-axis is x sub 2. The value of y on the y-axis on this part is y sub 1. And the value of y on this part is y sub 2. So to get the average, basically what we'll do is first get the middle of x sub 1 and x sub 2. And in the same way, we'll try to find the middle value of y sub 1 and y sub 2. So in that case, to get the x value of the midpoint, we'll have x is equal to x sub 1 plus x sub 2 over 2. And for the value of y, we'll have y sub 1 plus y sub 2 over 2. So let us have here the first example. So now let's try to answer some problems. For item number 1, we are asked to find the midpoint of the line segment whose endpoints lie on 2, 7 and 4, -3. And for the second item, one of the midpoint of a line segment is P sub 1 with coordinates -1, 3, and the midpoint of this segment is P with coordinates 2, -4. Find the coordinates of the other end. Now let's try to solve item number 1. For item number 1, We are asked to find the midpoint of the segment whose endpoints lie on 2, 7 and 4, negative 3. Since we already have the values for p sub 1 and p sub 2, we can just directly substitute it to our given formula. So for the x value of the midpoint, we'll have x sub 1 plus x sub 2 over 2. So substitute the values for x sub 1 and x sub 2, and that will be 2 plus 4 over 2. Simplify the numerator, that gives you 6, divided by 2, that gives you 3. And for the value of y, we'll have y sub 1 plus y sub 2 over 2. Then we'll substitute the values of y sub 1 and y sub 2 from our given. So that becomes 7 plus negative 3 over 2. Simplifying the numerator, that will give you positive 4. Dividing that by 2, that will give you 2. So therefore, the midpoint of the segment whose endpoints lie on 2, 7 and 4, negative 3 is 3, 2. Another example. One endpoint of a line segment is p sub 1 with coordinates negative 1 and 3, and the midpoint of this segment is 2, negative 4. Find the coordinates of the other end. So we'll still be using the same formula. So we'll have x is equal to x sub 1 plus x sub 2 over 2. But in this case, the known values are changed. Since we have p sub 1, meaning we have the value for x sub 1, and we also have the midpoint, so we can substitute a value for x. So meaning the unknown value here is x sub 2. So substituting the known values, we'll have 2 is equal to negative 1 plus x sub 2 over 2. Now to simplify this, is we need to cross multiply. So we'll have 4 is equal to negative 1 plus x sub 2. Then transposing negative 1 on the left side, we'll have 4 plus 1 is equal to x squared. And adding 4 plus 1, we'll have 5. So therefore, the value for x sub 2 is 5. So next is we'll try to get the value of y sub 2. So using the formula y is equal to y sub 1 plus y sub 2 over 2, substitute the known values, which are 3 for y sub 2 and negative 4 for y. So we'll have negative 4 is equal to 3 plus y sub 2 over 2, and that becomes negative 8 by cross multiplication is equal to 3 plus y sub 2. Next is we transpose 3 on the left side, so that becomes negative 8 minus 3 is equal to y sub 2. Adding negative 8 and negative 3 will have negative 11. So therefore, y sub 2 is negative 11. So therefore, in this problem, we can conclude that the coordinates of the other end is 5, negative 11. Now let's have division of a line segment. So we have here a theorem. The theorem says, if p sub 1 with coordinates x sub 1, y sub 1, and p sub 2 with coordinates x sub 2, y sub 2 are any two points in the coordinate plane, then the coordinates of the point p, x, y that divides p sub 1 to p sub 2 in the ratio r is equal to p sub 1 to p over p sub 1 to p sub 2 are given by x is equal to x sub 1 plus r times the quantity of x sub 2 minus x sub 1. And for our y coordinate, we have the formula y is equal to y sub 1 plus r times the quantity of y sub 2 minus y sub 1. So what does this mean? Now, given a line segment, what we will do is we will divide the line segment and we will try to get the points of divisions. Note that the value for p sub 1 to p and p sub 1 to p sub 2 are directed. So let's try to answer some sample problems for us to have a clear understanding of the theorem. So for item number 1, find the coordinates of the points that divide the line segment joining p sub 1 with coordinates negative 7, 0, and p sub 2 with coordinates 5, 6 into 3 equal parts. And for item number 2, the coordinates of the endpoints of a line are p sub 1 with coordinates negative 6, 2 and p sub 2 with coordinates negative 2, 4. If the line segment is extended 3 times its length through p sub 2, find the new point P. Now let's try to answer item number 1. Find the coordinates of the points that divide the line segment joining p sub 1 and p sub 2 into 3 equal parts. So before that, let us try to have a clear illustration of the problem. So on the illustration, we have here p sub 1. We also have p sub 2. Now what is asked in the problem is that for us to divide the line segment into 3 equal parts. Now if we wish to divide the line segment into 3 equal parts, there will be 2 points of division. So as you can see on the figure, we have this first point and the second point. These will be the points of division. So let's try to find the first point of division. So first is we have to look for the value of r. So to look for r, we have the formula p sub 1 to p over p sub 1 to p sub 2. So to look for the value of p sub 1 to p, we will just be counting how many equal parts will there be from p sub 1 to p. So from p sub 1 to p, there is just one part of the line segment. So that means the value of p sub 1 to p is 1. For p sub 1 to p sub 2, from p sub 1 to p sub 2, there will be 3 equal parts. So meaning the value of p sub 1 to p sub 2 is 3. Now to look for the coordinates of p, first is we have to look for the value of x. So to get the x coordinate, we'll use the formula x is equal to x sub 1 plus r times the quantity x sub 2 minus x sub 1. Substituting the known values, for x sub 1 we get negative 7 plus the value of r, which is 1/3, times the quantity of x sub 2, which is 5, minus the value of x sub 1, which is negative 7. Next step is to simplify 5 minus negative 7, and that can be simplified as 5 plus 7. Adding 5 and 7 will get 12. Multiplying 12 to 1/3, so that is 1 times 12 gives you 12 divided by 3, that gives you 4. So adding negative 7 plus 4, that gives you negative 3. Next is to solve for the y coordinate. So that is y is equal to y sub 1 plus r times the quantity of y sub 2 minus y sub 1. So substituting the known values, the value for y sub 1 is 0 plus the value of r, which is 1/3, times the quantity of 6, which is the value for y sub 2, minus 0. Next is to simplify 6 minus 0, and that is 6. Multiplying 6 to 1/3, that is 1 times 6, that gives you 6, over 3, that gives you 2. So adding 0 and 2, you'll get 2. Therefore, the coordinates of the first point of division is negative 3, 2. Now let's proceed to finding the coordinates of the second point of division. So we have here our illustration. The first point of division is negative 3, 2. And now we'll have to look for the second point of division. First is we have to look for the value of r. That is p sub 1 to p over p sub 1 to p sub 2. So again, the value of p sub 1 to p, that is 2 equal parts. So you have 2 over p sub 1 to p sub 2, that will be 3 parts. So you have 2/3. So it's time to look for the x coordinate. The formula for the x coordinate is x sub 1 plus r times the quantity of x sub 2 minus x sub 1. So substituting the values for x sub 1, x sub 2, and r, we'll have negative 7 plus 2/3 times the quantity of 5 minus negative 7. Now simplifying the value inside the parenthesis, we'll have 5 plus 7. Adding 5 and 7 will get 12. Getting 2/3 of 12, we'll have 2 times 12, which is 24. Divided by 3, we'll have 8. So adding negative 7 and 8, we'll have positive 1. That means the x value for this point of division is 1. Next is getting the value of y. So to get the value of y, we have the formula y sub 1 plus r times the quantity of y sub 2 minus y sub 1. So substituting the values of y sub 1, y sub 2, and r, we'll have 0 plus 2/3 times the quantity of 6 minus 0. So simplifying 6 minus 0, we'll have 6. So next is multiplying 2/3 by 6. So that's 2 times 6, that's 12. Dividing it by 3, we'll get 4. So 0 plus 4 is 4. So that means for this point of division, the coordinates of P is 1, 4. Therefore, the points of divisions are negative 3, 2, and 1, 4. Now, this type of example is called division of a line segment divided internally, since the points of divisions lie within the line segment. Now, let's have the second example. For the second example, the coordinates of the endpoints of a line are P sub 1 with coordinates negative 6, 2, and P sub 2 with coordinates negative 2, 4. If the line segment is extended 3 times its length through P sub 2, find the new point P. Now let's take a look at this illustration. So what we have on the given is P sub 1 with coordinates negative 6, 2, and P sub 2 with coordinates negative 2, 4. Now what is asked in the problem is to extend the line 3 times its own length through P2. So that means if this is P sub 1 to P sub 2, we will extend it 3 times its own length. So that's first, second, and third. So this will be the new point P. Now to start solving the problem, first is we have to look for the value of r. So the formula for r is P sub 1 to P over P sub 1 to P sub 2. So that means you have from P sub 1 going to P, there are 4 equal parts. So that's 4. From P sub 1 to P sub 2, that's just 1 part. So the value of r is 4 over 1, or simply 4. Now, since we have the value of r, which is 4, let's try to get the value of x, the x coordinate of point P. So the formula is x is equal to x sub 1 plus r times the quantity of x sub 2 minus x sub 1. Now, let's substitute the values for x sub 1, x sub 2, and r. So this will be negative 6 plus 4 times the quantity of negative 2 minus negative 6. So first is we have to simplify the value inside the parenthesis. So that is negative 2 plus 6. Now adding negative 2 and 6 will get positive 4. Now next is to multiply 4 by 4, that's 16. Adding negative 6 will get 10. So therefore, the x-coordinate of this point P is 10. After getting the x-coordinate, we'll proceed with getting the y-coordinate. So the formula is y is equal to y sub 1 plus r times the quantity of y sub 2 minus y sub 1. So substituting the values from our given, you have 2 plus 4 times the quantity of 4 minus 2. So getting the difference of 4 and 2 will have 2. So multiplying 4 by 2 will get 8. Adding 2 to 8 will have 10. So therefore, the value of the y-coordinate is equal to our x-coordinate, which is 10. So therefore, The coordinates of P in this problem is 10, 10. Now in this type of example, this is called division of a line segment divided externally, since point P is outside the given line segment from P sub 1 to P sub 2. And that's the end for this video. See you on the next lesson.